Hello everybody. Now we shall discuss about haze bridge. Let me draw haze bridge. In case of Maxwell's inductance capacitance bridge, resistor and capacitor are connected in parallel, whereas in case of haze bridge, these two are in series. Resistance and capacitance are connected in series. Detector. AC voltage applied to this bridge. Let E is the voltage applied to this bridge. Let this is R1, L1, R3, R2, R4, C4. The voltage across this branch, let E1 is the voltage across this branch, let E2 is the voltage across this branch, let E4 is the voltage across this branch, E3 is the voltage across this branch. The current which is flowing through this is I1, current flowing through this is I2. I2. The current flowing through this is I3. Current flowing through this is I4. I4. When no current is flowing through this detector, then the bridge is said to be balanced. These two are variables in this bridge, C4 and R4. Okay, in case of Maxwell's inductance capacitance bridge, these two are in parallel, whereas in case of Hayes bridge, these two are in series. So L1 is unknown inductance, R1 is unknown resistance, R3 and R2 are non-inductive resistances. Non-inductive known resistances. Known resistances. R4 is variable known resistance, standard variable known resistance. C4 is variable known capacitance. Under balanced conditions, under balanced conditions, Z1, Z4 is equal to Z2, Z3. What is Z1 here? R1 plus J XL1. Okay, what is Z4? Let me write over here. Z1 is R1 plus J XL1. What is Z4? R4 is in series with C4. Then what will be the impedance? Impedance will be R4 minus J by omega C4. What is Z2 is R2. Z3 is R3. Okay, then R1 R4 minus J R1 by omega C4 plus J R4 omega L1. XL1 is nothing but omega L1 minus, okay, minus of J square, nothing but plus. J square is minus, nothing but minus 1, right? Minus of minus, nothing but plus J omega L1 by omega C4 is equal to R2 R3. So R1 R4 plus L1 by C4 is equal to R2 R3. Okay, if I equate both real and imaginary parts separately, okay, otherwise let me write equate real and imaginary parts separately. Then let this is equation 1. You are going to get one more equation, that is L1 is equal to R1 by omega square R4 C4. Equating real parts, you're going to get equating imaginary parts, you're going to get this. Okay, this is equation 2. Equation 2. Solving both equations. Otherwise, put equation 2 in equation 1. Then you're going to get R1 R4 plus, in place of L1 you write this R1 by omega square R4 C4 square is equal to R2 R3. Okay, from this you're going to get R1 is equal to omega square R2 R3 R4 omega, sorry, C4 square by 1 plus omega square C4 square R4 square. Okay, now put equation 1 in equation 2. Then you're going to get equation 1 in equation 2. Okay, otherwise I will do one thing. From this equation, from equation 2 we get R1 is equal to omega square L1 R4 C4. Okay, let this is equation 3. Okay, so put equation 3 in equation 1, you're going to get L1 is equal to R2 R3C4 by 1 plus omega square C4 square R4 square. Okay, after solving these two equations, okay, you're going to get R1 and L1 like this. So what is R1 now? R1 is equal to omega square R2 R3 R4 C4 square by 1 plus omega square C4 square R4 square. What about L1? L1 is equal to R2 R3 C4 by omega square, sorry, 1 plus omega square C4 square R4 square. Okay, R4 square. Okay, so R1 is equal to omega square R2 R3 R4 C4 square by 1 plus omega square C4 square R4 square. L1 is equal to R2 R3 C4 by 1 plus omega square C4 square R4 square. Now let us find Q factor. Q factor, quality factor of the coil. That is Q is equal to, omega L1 by R1, which is equal to omega R2 R3 C4 by 1 plus omega square C4 square R4 square. By what is R1? Omega square R2 R3 R4 C4 square by 1 plus omega square C4 square R4 square. Both will get cancelled. Then we are going to get omega R2 will get cancelled, R3 C4 and here C4. Then you are going to get 1 by omega C4 R4. So finally Q is equal to 1 by omega C4 R4. This is the expression for Q factor in case of phase bridge. Okay. Now if R4 is small, if R4 is low, means Q will be high. So for the measurement of high Q coils, low resistance, that is R4 is required. Low resistance is required. Okay, so this bridge is suitable for the measurement of high Q coils. Q greater than 10. Okay, because low resistance is required. Okay, low resistance of decayed box is required. Okay, so using low resistance we can measure high Q factor coils. Okay, high Q coils. Okay, so for the measurement of high Q coils we require low resistance. Okay, so this bridge is suitable for the measurement of high Q coils, that is Q is greater than 10. If Q is greater than 10, this is suitable for the measurement of Q coils, high Q coils, that is Q greater than 10. Now For high Q coils, for high Q coils, for high Q coils, what will be the expression for inductance? You know, L1 is equal to R2 R3 C4 by 1 plus omega square C4 square R4 square. This can be written as R2 R3 C4 by 1 plus 1 by Q square. 1 by Q square. Okay, if for high Q coils means Q greater than 10, right? Q greater than 10 means what about Q greater than 10 means what about this 1 by Q square? 1 by Q square will be 1 by Q square will be uh, equal to what? 1 by 10 square, that is 1 by 100. Okay, so this part will be 1 by 100. Okay, if it is equal to, if Q is equal to 10, then 1 by Q square will be equal to 1 by 100. Means for Q greater than 10, 1 by Q square will be less than 1 by 100. Okay, so this can be neglected. Okay, so you neglect this part. If you neglect that, then L1 is equal to R2 R3 C4. This expression is same as the expression for inductance for a Maxwell's bridge. Okay, for Q greater than 10, you're going to get expression for inductance. Okay, now coming to the advantages. You can also find expression for R1. R1 will be equal to omega square R2 R3 R4 C4 square by 1 plus 1 by Q square. Then if we neglect this, R1 will be equal to omega square R2 R3 R4 C4 square. If we neglect this, coming to advantage, this bridge gives very simple expression for unknown inductance. Very simple expression for unknown inductance for high Q coils. That is Q greater than 10. This bridge gives simple expression for Q factor. Okay, here expression for Q factor is very simple. This bridge is suitable for the measurement of high Q coils. that is Q is greater than 10. Coming to the disadvantage, this bridge is not suitable for the measurement of low Q coils. That is Q is smaller than 10. Okay, so this bridge is not suitable for the measurement of Q coils, low Q coils, that is Q is less than 10. Okay, or this bridge is not suitable for the measurement of Q coils less than 10. Or let me write like this. Measurement of coils having Q less than 10. Okay, if you want to measure uh, Q coils less than 10, it is better to use Maxwell's switch, Maxwell's inductance capacitance switch. It is used for the measurement of medium Q coils. That is Maxwell's inductance capacitance bridge is used for the measurement of medium Q coils, 1 greater than Q less than 10. Okay, if Q is less than 10, we use Maxwell's inductance capacitance bridge. Okay, if Q is less than 10, this bridge is not suitable for the measurement of coils. If Q is less than 10, if Q is greater than 10, then only this bridge is suitable for the measurement of coils. Coming to phasor diagram. So finally, Hayes bridge is suitable for the measurement of high Q coils. Suitable for the measurement of high Q coils, that is Q is greater than 10. Now let me draw the phasor diagram. Let me take current as reference vector. This is I1 which is equal to I3. Under balanced conditions, I1 is equal to I3. So I1 is equal to I3. Let us draw the voltage across R1. Voltage across R1 will be in phase with I1. Voltage across R1 is in phase with I1. So this will be voltage across R1, that is I1 R1. Now let us draw voltage across inductor. Voltage across inductor leads current by an angle 90 degrees. So this will be what? This will be voltage across inductor. I1 omega L1. Fair sum of voltage across this and voltage across this gives E1. So voltage across this and voltage across this gives E1. So this will be E1. E1 E1 is equal to E2. E1 is equal to E2 because voltage across this will be equal to voltage across this. Both are equal under balanced conditions. E1 is equal to E2. So E1 is equal to E2. Now this part is completed. Coming to this, how can I draw E3? E3 is the voltage across R3. You know phasor I3. Let us draw E3. E3 will be in phase with I3. Okay, so let us draw E3. This will be E3. E3. E3 is equal to I3 R3, which is equal to E4, which is equal to E4. Okay. Now, how can I draw I2? Anyhow, I2 is in phase with E2, or E2 is in phase with I2. So let me draw I2. So I2 will be like this. In phase with E2. So this will be I2. This will be I2 is equal to I4 because both are equal. Current flowing to this will be equal to current flowing to this. Okay, now how can I draw the voltage across this C4? Voltage across C4 lags current through C4 by an angle 90 degrees, or current through this C4 leads voltage across this C4 by an angle 90 degrees. Okay, so now voltage across this C4 lags current by an angle 90 degrees. So anyhow, this is the current which is flowing to this C4. Now let us draw voltage across C4. Voltage across C4 will be okay 90 degrees. The angle between these two will be 90 degrees. Okay, this will be what? This will be I2 by omega C4 or I4. I2 by omega C4 or I4 by omega C4 or I4 by omega C4. Okay. Now we know E3. E is phasor sum of E1 and E3 or E2 and E4. So phasor sum of E1 and E3. E3 E3 will be E. This will be E. So this will be E. Okay. Now this E4 is phasor sum of voltage across this and voltage across this, right? How can I draw voltage across this? Voltage across this will be in phase with I4. Okay, so now let me draw this voltage will be in phase with E4. Sorry, voltage across R4 will be in phase with I2 or I4. So this will be E2R4, E2R4, E2R4 or I4R4. Okay, now phasor sum of this and this gives E4, right? So now fair sum of voltage across capacitor. Voltage across capacitor. Fair sum of voltage across capacitor. Sorry. Okay. Fair sum of voltage across capacitor and voltage across R4. Voltage across R4 and voltage across capacitor will be E3 or E4. Okay. So voltage across C4 and voltage across R4. Fair sum of these two is what? E3. 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 Okay. Fair sum of voltage across R4, voltage across C4. Fair sum of these two is what? Fair sum of this and this is what? E3. E3 or E4. E4 or E3. Okay, both are equal. Okay. Thank you.